Thank you very much, Jay. It's for me a very special talk, this one. I will try to be efficient to provide this information during this amazing 25 years. So there are many collaborators, many more than are included here in the references and beyond. But let's start with one motivating question that all of you know the answer. What is this, for instance? What is this? Yeah. For instance, keeping the right figure, as you know, they represent for a given time one global ionospheric map for one IGS center of the vertically integrated electron number density, so-called vertical total electron content, obtained from hundreds of permanent lone receivers from IGS network, as you know very well, multi-frequency receivers. So they represent these metrics of the electron content vertically considered of the Global Ionosphere. And also they provide from one of the files containing this information in Unix format. In particular, this corresponds to the day, the left one to the 9th of May at 0 UT, and the next one, 11 May 2024 at 7 UT. You can see the different scales during the especially the perturbations here in America in this case, associated to 1 million stone, as you know very well, the largest in 21 years. So this is just one very recent example of something that is has been developed during 25 years. So one way to develop this is to consider like some hints. There are many hints, but we selected this set of hints moving forward in the Ionosphere Working Group for the generation of the Global Ionospheric Maps in the community. First one, at T0, we can say the day 56, 1998, the date of the publication, was the definition of a rules format for VTEC GIMs. This contribution from Stefan and from Professor Burner and from Joachim, it was very important in my understanding, because this provides a strong foundation for providing and sharing the data in a common format, also for the VTEC error RMS estimations. So this was a very good starting up. By the way, you can see I have used as calendar the time series of the global electron content, the total number of free electrons in the ionosphere obtained from the global ionospheric maps. Okay. Some weeks after it was started the common IGS VTEC GIM, started the production, the comparison of, the generation from different centers, code, SpaceINC, ISOC, NRK, GPL, UPC, SST-time, the computation with different techniques of the global ionospheric maps: computation, comparison, and assessment and combination. And this started on June 1st, the 1st of June of 98, 6 years ago approximately. So in this regard, we can see this is something that was at such a time at this time, Joachim published a paper where he talked about the need of refining the algorithm and also to realize near real-time availability. This was also something to be important to start thinking on the near real-time or real-time at such a time. Afterwards, in the next, let's say, another hint is the first external validation of IGS VTEC GIMs and beyond, let's say. This was summarized in one paper, a common paper in 2009. What was the situation? I mean, of course, we organized and we set up flow, more or less following the same successful chain of assessment, weighting combination for other products, for products which were done orbits and, for instance, rocks. So we follow the same philosophy, but we have some problems. I mean, specific problems. For instance, at the top left part, you can see what can be obtained directly from data. When you obtain from the measurements, when you consider the available ground receivers. And we found big holes. And at such a time, I remember, I was happy because in the Ionex format, I don't know if it's Stefan's over here, in Ionex format, there is the ID 9999, 4 nines, that means no availability. I was happy with that because I was thinking, okay, so let's provide the VTEC where we have illuminated information. So this was something that was also a challenge to look for efficient operation methods. But the things were in the right way. The comparison between them was quite good, considering different techniques. These are 4 GIMs comparing different techniques at the same time. This is an example. Also, they compare well with the solar indices like solar flux. The combined were well correlated with the solar flux, and also very well correlated with independent measurements with the JSON VTEC, considering comparing with the JSON VTEC measurements or JSON and topics, altimeter independent VTEC measurements. So in 2012, the International GNSS Real-Time Service started. The idea was proposed by an award led by Mark Icey, Luis Arlotis, and other colleagues, and also Urs. I guess Urs is here too. And this was important because we started in this very challenging scenario of real time. You get the measurements in less than 2 seconds in your computer, but you need to process efficiently, to maintain the availability of the service. It was very, very challenging. In 2018, a new campaign of IGS VTEC GIMs external validation was performed. And here we were able to compare in a little detail that in the previous campaign, the different methodologies, and also the performance using external reference values, DSTEC for over long receivers, and altimeter during one solar cycle, different altimeters, also filling the different calibration of the altimeters that focus for comparison on standard deviation, mostly. In 2020, a first external validation for real-time GIMs was performed in a work led by VTEC, also involving all the centers. So it was the first time after, let's say, 8 years of the starting of the real-time working group. And the comparisons was, of course, we saw that we had to improve. In our case, in particular, for instance, you can see the real-time, the clicking was not working so well in real-time that in post-processing, but was quite a good comparison and study. And we completed this study we extended this study 1 year after, also involving all the centers and also new centers, like in Associated KNS, UPC, Chains of Science, and now also Wuhan University. The main points were available. We did the assessment every 20 minutes, for instance, in our combination center at UPC, with 2 combination centers at CAST at UPC, and the assessment is performed every 20 minutes, is combined, is broadcast the combination, and the assessment is quite good. I mean, you can see, especially after the update we did, the red was the UPC with green in real time, but in the 6th of January of 2021 is the day of the Magic Kings in Spain, when the kids wait for the toys during the night in camels. So in this we implemented the new technique based on face recognition, and you can see the good improvement and also the impact on the combination, the black line in the combination. And the performance was very close to the rapid and final performance. So we were very happy, as well from the point of view of the DS-TEC test. But beyond Global Ionospheric Maps, in the shadow or in the umbrella, more than in the shadow of the Iono Working Group, there are products that are being generated, like IGS VTEC Maps products, officially since 2015 and broadcast and distributed from NASA's IGS server. Also very important in the recent space weather storm in May. Many tractors for process locator stopped due to the high ROTI and problems with the availability of the satellites. And also the GNSS solar astronomy, let's say, that with the same data that we are generating global GIMs in real time, we are estimating the UV flux rate of the sun, working quite well and comparing quite well with the sun. Conclusions and potential evolution considering recent results. I mean, the Iono Working Group of IGS has been improving the generation, assessment, and consistent combination, providing millions of VTEC GIMs. This has been done in a friendly collaboration. This, for me, has been very important and motivating, and learning in common, also in the extended 24/7 real-time service. New operative ionospheric products are also developed under this umbrella, like ROTI maps and UV flux rate process in real time. And there are many ways to move forward, like GIMs of electron density, generation of GIMs of VTEC gradient, or space weather semaphores, GIMs of space weather semaphores. And the last, just one slide about the comprehensive tsunami early warning team mission looking for international support that was proposed by Professor Oscar Colombo, that unfortunately passed away a bit more than 1 month ago. So thank you.